Hi all. So this is from the lecture for MATLAB/Octave number 4. So this kind of sums up most of the topics for this particular week. It's similar, but I've changed it slightly from the problem in the PowerPoint slides. So feel free to take a look at that one, and the outputs are actually in the PowerPoint slide presentation also. But we'll run through this one together. So first line of code here has a prompt for the user. So we're using the input command, assigning to the variable v an initial velocity in meters per second. So it's what the user will see is this enter initial velocity in meters per second and a cursor to allow them to enter the value. All right, gravity we know is 9.81 meters per square second. All right, we're setting the launch degrees between 0 and 90 degrees in 5-degree increments. We need to convert those to radians because, again, remember in Excel that we used before, MATLAB and Octave all do their trig calculations in radians, not in degrees. So you need to convert your radian values or your degree values to radians to do your calculations. All right, the range formula is something we've seen before in the previous problems that we did. And then the last part is actually creating the table. So we're using these fprint commands to create both the headers and create the table itself. So the header in this particular case is I'm doing a new line after the prompt, so it's not right underneath her, printing the word degrees, putting a few tabs, and then putting the word range, new line. Underneath that, I'm putting the values for degrees and for range, putting a couple of tabs in between them so that hopefully it spaces out. So let's run the program now. So run the program, we see nothing happening here, but if we go to the command window, you see there's the prompt that we talked about, the enter the initial velocity in meters per second. Let's do 125. So I'll enter that in. Notice there's a new line, and then we have my table of degrees and range. I will tell you one thing that is different between Octave and MATLAB is the formatting is slightly different. You might get it to look good in MATLAB and not necessarily in Octave, or vice versa. This I am doing in Octave. So you can see my degrees from 0 to 90 in 5-degree increments, and you can see the calculated range, and of course that would be in meters. And again, always remember, right, if you can shoot up 90 degrees, if you can shoot straight up in the air, you better run because it's going to come right back at you.